Write each expression in expanded form. All right, so what they want us to do here is to express the logs as a sum or difference of logs, and also to express the powers sort of as products, multiplying the log out in front. So let's take a look at the first one. We have log of 64y base 8. So we can take that product of 64y and we can rewrite it as a sum. So we can certainly say log of 64 base 8 plus log of y base 8. So multiplication leads us to the addition or sum of two logs. Now from here, we can certainly rewrite that log of 64. 64 is 8 squared. So I should be able to say log of 8 squared base 8, right? Plus log of y base 8. And then we can bring the 2 out in front here, right? And then the 2 goes in front to say 2 times the log of 8 base 8 plus log of y base 8. Now from there, the log of 8 base 8 is just 1. So we can say 2 times 1 is 2. And so the final answer for this problem is that 2 plus the log of y base 8. All right, very good. All right, from here, let's do example B. So example B has a fraction, and we can then use this second property in our list, which says the log of a divided by b can be expressed as the log of a minus the log of b. So we should be able to rewrite this as the log of x squared base 3 minus the log of y cubed base 3. All right, very good. From there, we can bring the exponents out in front as well. So this exponent can come here, and this exponent can go there. So we'll end up saying that it's 2 times the log of x base 3 minus 3 times the log of y base 3. So there it is in expanded form, and we can't do anything more to it, so we're going to leave it just like that. Okay, let's go ahead and work out C now. So again, we have a fraction in C, but we have a whole bunch of other things going on as well. So C is a little bit complicated. Let's start with a fraction though. The fraction can be written as a difference of logs. So we'll go ahead and say log of a squared times a minus 2 to the third power minus log of the square root of a plus 1. So that's the first step. We turn the fraction into subtraction, right? All right, from there we can turn this product here into a sum. Again, remember we have a single log of a product, so we're going to write it as two logs added together. So we're going to say log of a squared plus log of a minus 2 to the third power minus log of the square root of a plus 1. All right, so we've rewritten the product and rewritten the original fraction. Now we have to deal with the exponents, right? So this 2 can come out in front, and this 3 can come out in front. So we'll end up saying now that we have 2 times the log of a plus 3 times the log of a minus 2 minus log of a plus 1 to the 1/2 power. So I'm writing the square root as a rational exponent, and that will be our final step here, just to pull this 1/2 out in front. And that's the very last piece. So we'll have 2 log of a plus 3 log of a minus 2 minus 1/2 log of a plus 1. And that's it. There's nothing we can do further. We aren't able to, don't try to distribute this log in here or something like that. You can't do that, right? The log is kind of like a square root in that way. You know, you take the log of something, right? You can't distribute a square root. A square root doesn't exist without a radicand, right? So same kind of thing here. We're not able to distribute log. That doesn't work, right? So log of a minus 2 cannot be simplified any further. So we're done. All right, and lastly, let's go ahead and tackle problem D. So we'll give ourselves a little room to work out D. First, it's a fraction, so we need to express it as a difference. So we'll say ln of 3y to the 4th power times the square root of 1 minus y minus ln of 4y plus 1 to the 3rd power. All right, so that's good. We've turned the fraction into subtraction. Then we have a couple of products we got to work with. Products can become what? Addition, correct? So we're going to rewrite the products as ln 3 plus ln y to the 4th plus ln of the square root 1 minus y. All right, and then we're going to have minus, and then we have another product. Now here you want to be careful. Because we have a product in the denominator, we want to actually use a bracket here to indicate the minus is going to distribute in here. So ln of 4 times y plus 1 to the 3rd can be rewritten as a sum, but it needs to be ln of 4 plus ln of y plus 1 to the 3rd power, right? So we're taking this product and writing it as a sum, but remember we have a minus sign out in front, so the minus has to be put out in front of the parentheses. You can distribute it in after if you want, but the point is it has to be there first. You can't forget to distribute it into the entire expression. Okay, so now we can distribute it in if you'd like. We can take this negative and apply it to both pieces, right? So we will have ln of 3 plus ln of y to the 4th plus ln of, I'm going to rewrite this as 1 minus y to the half power. To write the radical as a rational exponent is always useful, so let's do that. Then we're going to have minus ln of 4. 4 can actually be written as 2 squared if you want. And then minus ln of y plus 1 to the 3rd. Okay, so there's a lot going on here, but we're almost done. The final step to expand this out is to bring these exponents that we have out in front. So we can bring the 4 out in front here, for example. So we'll have ln, let me just separate d and c. It's a little bit busy on the paper here. So we'll have ln of 3. The 4 will come in front to be plus 4 ln of y. The half will come out in front to make it plus 1/2 ln of 1 minus y. Then the 2 will come out in front here to be minus 2 ln of 2. And then the 3 will come out in front here to be minus 3 ln of y plus 1. And after all of that, we are finally finished. We've written this in the simplest form that it can achieve. And what I mean by simplest here is not to say it's simple. It's actually quite complicated. It's fully expanded. Maybe you would say originally it was in simplest form. What I mean by that is that we've expanded it out as far as we can, and we really can't do anything more to expand it further or to simplify it any further. So that's basically it.